Is it recording? Yes, it is. Good. Okay, so this is 7th grade 6-4. You're making more comparisons here. So let's turn the page. And they're giving you some dot plots in example 1. And I'm looking at step 2 here. It says use the dot plots to compare the two data sets. And so here's the data sets, the green and the blue. And they point out here that the mode is 24 for this one right here. And the mode in this one is 28. And if you guys remember that the mode is the one that occurs most often. Going back to the first one here, the green one, the range is 7. Remember, the range is from the lowest data set to the highest data set. And this one, the range is 9, going from 21 all the way to 30. And down below that, it says the number of curl-ups completed this year is generally greater than last year. And but based on the shape of the data, not all the students made the same progress. So down below at the try it says Quinn also collected data about push-ups. Does it appear that the students generally did more push-ups last year or this year? And explain your reasoning. So that's what I put. I put down more this year. That would be the blue right here. And I think just looking at the chart, you guys can tell that as a rule of thumb, generally more push-ups happened this year. So more this year, there are more dots associated with higher numbers. So 11 has 2, 10 has 2, 9 has 2, 8 has 3, 7 has 3. Well, you come over here, go all the way down to 7. 7 has 2, 8, 1, 9, 1, 10, 1. So it's obvious more push-ups were completed this year. And then they convince me and says, how does the range of the data sets affect the shape of the dot plots? Well, the greater the range, the more spread out the dots. I mean, it's kind of a no-brainer. If you have a greater range, it's going to cover more area and the dots will be spread out more. Example 2, you'll see this abbreviation every once in a while, MAD, M-A-D, and it stands for mean absolute deviation. In other words, how far the data is from the mean. Now, if you don't remember what mean is, you guys should have written this down a while back, a couple weeks ago. Turn back to page 33. Turn back to page 33 in your workbook. And I had you guys copy this down. Mean is the average of all the numbers. I'm sorry, what?
We don't have a 33.
Did I say 33? I meant to say 333. My bad.
It's better.
Yeah, that's better. So page 333, if you go back to that, mean is the average. You'd add up all the numbers. So let's say there's 12 numbers. Add them all up and divide by 12, and that would give you the mean. That's the average of all the numbers. The median, as you guys know, I just mentioned that a few minutes ago, is the middle number, and the mode is the one that occurs most often. And then the range, we were just talking about that also. So let's see here. Quinn computes the mean and the mean absolute deviation, or MAD, for each data set. And they ask the question, how do these measures support Quinn's inference from the data displays? And so you can, looks like they're talking about curl-ups last year. And looks like the point is 23 and 24 and 25. And for this year, it looks like the high points would be 27, 28, and 29. Let's see here, example 3. Let's look at the try it down below here. It says Peter surveyed a random sample of adults and a random sample of teenagers. So some adults and some teenagers. And it's about the number of hours they exercise in a typical week. He recorded the data on the table below. What comparative inference can Peter make from the data sets? So it's not a dot plot at all. It's just some information here. So the mean for adults is 4.4. So they're averaging 4.4 hours that they exercise in a typical week. And teenagers, it's almost 8, 7.9 in a typical week. And the MAD, which is the mean absolute deviation, how far the data is from the mean, it's a little bit tighter for the teenagers and a little further for adults, but not enough to really make any kind of difference. But what could you say about this information, this chart here? Don't make it harder than it is. What could you say? Yeah.
Teenagers get more exercise?
Yeah, teenagers exercise more than adults. In fact, just about almost 2 times as much as adults. All right. Key concept. I just circled number 1 and drew a line, an arrow up here. You can use dot plots to make informal comparative inferences about 2 populations, and you can compare the shapes of the data or measure the center of variability. I think dot plots more than box plots give you much better visual aid. So you'll write that for number 1. Number 2 I scratched out. Number 3, it says 2 data sets have the same mean, but one set has a much larger MAD than the other. Explain why you may want to use the median to compare the data sets rather than the mean. And so here's what I put down. I said, if the mean, and then I defined it by putting it in parentheses so you guys don't forget. If the mean, average of all the numbers, close parentheses, is the same, then the median might be a better explanation in the greater variability. Okay? If the mean or average of all the numbers is the same, then the median might be a better explanation. I didn't phrase that quite right. Might better explain the greater variability. And again, if I'm going too fast, you guys can rewatch the video. And page 351, number 6, I circled all 4 of those boxes. Number 7.
What about the, how do you
Oh, yeah, I'm sorry. Thank you. Circle 4, 5, A, and B. Do those 3. And 6. Answer all those. 7. Circle those, 4 of them. Number 8. It says a researcher divides some marbles into 2 data sets. In data set 1, the mean mass of the marbles is 13.6 grams. In data set 2, the mean mass of the marbles is 14 grams. The MAD of both data sets is 2. What can you infer about the 2 sets of marbles? And so I just put, since both have a MAD of 2, there is not much difference. Since both have a MAD, M-A-D of 2, there is not much difference. Circle number 9, top of page 352. Number 10, higher order thinking. And it's in reference to the items built here. Scratch out B, but I do want you to answer A. And it says, which measures of center and variability should be used to compare the performances of each machine, and explain. You don't need to explain it, but you are going to pick 2 of the 5 that I've listed here, and so I'll put that down, but I'm going to make this worth a stick.
Is it graded?
It is not graded. And so if you miss one or both, I'm not going to tell you tomorrow. I'll just keep pulling sticks until somebody gets the 2 that you're to pick from these 5 correct. And let me put not graded. And then number 11, you'll choose one of those. And then is that, yeah, that's it for chapter 6. Then we'll be starting the chapter review tomorrow. And then, of course, Wednesday we're going to be off going to San Francisco.